Okay, so this is for Algebra 2 1.6. So we're looking at starting to put together compound and absolute value inequalities and kind of the role that those play when compared to just regular inequalities and kind of how that relates to information. So we start here. When you're trying to determine if someone is diabetic, they do what's called a glucose tolerance test. And kind of the rule is that if you need to be fasting, that means you got no food or drink except water for at least 10 but no more than 16 hours. So that's kind of that sweet spot right in between 10 and 16. So the acceptable number of hours for fasting by using an inequality. So if H is my hours, it's got to be no more than 16, but it's got to be bigger than 10. So kind of the way that you write that is like this. This is called a compound inequality. So it's got to be less than or equal to 16, but if you kind of read this, 10 is less than or equal to the number of hours. All right, so it's kind of putting two statements together in one. So compound inequalities are usually joined by the words and or the word or. So let's kind of start here. Consists of two inequalities joined by the word and or by the word or, and inequalities are true if and only if both inequalities are true. So x is greater than or equal to -1 and x is less than 2. This is what that looks like on a number line. Please notice that you're in a range from here to here. That is kind of how the and works. Or means you're looking for the space. Okay, or means you're going to go the opposite direction. So you've got x less than or equal to 1 or x is greater than 4. You've got this range or this range. So it's kind of, you got to think logically a little bit about this. If I go back at and, this has to be true and this has to be true. So both of them have to be true. So there's only a limited area you can look at where that's true. There's only a limited amount of numbers that are bigger than -1 and less than 2. All right, or is a little bit different. Or says it's either got to be this or this. I don't care which. It says it's either got to be less than -1 or bigger than 4. I don't care which. All right, so that's why or is a little bit more relaxed with where you're trying to look. All right, and means it's got to be in one little focused area, or means it's got to cover a lot of ground. So take a look. This would be a compound inequality. So 13 is less than 2x plus 7, less than 17. So now a couple different ways you can do this. One, you can split it apart and solve each piece. So I could do that. So I could subtract 7, subtract 7. A little quick work. So 3 is less than x. Over here, subtract 7, subtract 7. 2x is less than 10. X is less than 5. So then I could put this back together. So 3 has got to be less than x has got to be less than 5. Okay, that's one way. So if I sketch it on a number line, x has got to be between 3 and 5. So 0, 1, 2, 3, 4, 5. So here and here. So this is going to be and. So 3 is less than x, so x is bigger. So you're looking at this area right in here. Now, another way to do it is to kind of, instead of break it up into two pieces, just kind of do it all together. What that looks like is this. So if I subtract 7, I'm going to subtract 7 here and subtract 7 here. I do it to the inside and the outside. So this gives me 6 less than 2x less than 10. Now, I got to divide by 2. I divide everything by 2. So 3 is less than x is less than 5, which is exactly what we had over here before. So it's going to be that same graph. Either way, if you feel comfortable doing it that way, do it that way. If you feel better splitting it apart, split it apart. It's dealer's choice on that one. So here's what we got. X is less than or equal to 3x. 8 is less than or equal to 3x minus 4 is less than 11. So I want to add 4 to both sides. So that's going to be 12 less than or equal to 3x less than or equal to 15. Divide everything by 3. So that's going to be 4 less than or equal to x less than 5. So that's going to be a very, very small window there. And again, I could have split it up. I could have said, you know what, over here I'm going to do 8 less than or equal to 3x minus 4. And over here I'm going to do 3x minus 4 less than 11. If I do that and put it back together, I'll still get this. So now when I put it together on a number line, one, two, three, four, 5. There's 4, there's 5. 4 is going to be less than or equal to. 5 is going to be just less than. So it's going to be just this little window in there. Or is a little bit different. Or means you've got 2 of them, and this is the ones where they go out in the opposite direction. Okay, so this is the one that says all of this is true, and all of this is true. So this I'm going to definitely take apart. So x plus 5 is less than or equal to 7, or x minus 6 is greater than 2. So if I subtract 5, I subtract 5 here, subtract 5 here. X has got to be less than or equal to 2. Or add 6, x has got to be greater than 8. So now, that is my ranges. So I've got to do both of these. 1, 2, 3, 4, 5, 6, 7, 8. Let's go 9. So 2, it's got to be a full circle because that's equal to. So I'm going to go up and go that way. 8 is an open circle because this is just greater than. I'm going to go out. So that is what an or looks like. Or should go in opposite directions and should go towards each other. Absolute value. Okay, so absolute value is your distance on the number line away from 0. So absolute value of 7 is just going to be 7. Absolute value of negative 2 is just going to be 2. Absolute value of some number equals 3. Well, that's going to be 3 and negative 3. Both of those give you the absolute value of 3. If I throw the absolute value of negative 4 there, well, that's going to be 2 pieces. That's going to say either x is less than 4 or x is greater than negative 4. Notice, basically all I did was take the exact expression or exact inequality and just take away the absolute value. And then I also said, I'm going to say less than negative 4. I'm going to switch this. I'm going to switch this sign and I'm going to switch this sign. So this is going to be an or situation. All right, so it's x less than 4 or x greater than negative 4. So x less than 4 is going to be an and situation. If it's greater than, it's going to be an or situation. So make sure you kind of understand this. So like I had it on the last page, this is either going to be x minus 4 or x greater than negative 4. So remember, or is going to be pointing in different directions. I'm sorry, this is going to be and. Sorry, not that one. And x greater than negative 4. And I'll show you what I mean in a second when I graph this. So if you look on a number line, if I just sketch a quick number line, negative 4 and 4, Well, this is going to be an open circle here and an open circle here. But less than 4 is going to go this way. Greater than 4 goes this way. So you're going to be in between here. This is all the numbers that fit this category, so you can even test them. So does -2 work, and does 1 work? Well, does -2, the absolute value of -2 less than 4? Yeah, that checks out. That's fine. Is the absolute value of 1 less than 4? Yeah, that checks out. That's fine. All right, so if it's less than, it's going to be and. And there's a reason. That rhymes. Less than and. This is kind of the one. Greater is or. Greater is or. So if I've got x greater than or equal to 4, that's that same kind of idea. I'm going to split it apart, but it's going to look like this. I'm going to have absolute value. I don't want absolute value. I'm going to have x greater than 4 or x less than -4. So if I do a quick sketch on a number line, so x greater than 4, that's an open circle, but this time it's going out. X less than -4 is an open circle, but this time I'm going out that way. So greater is or. Less than is and. Okay, that's how you kind of want to remember that. So kind of just another way to think about this. Less than, greater. It's kind of the way you want to think about it. And here's kind of the algebraic way to say it, just kind of in general. It's kind of your general rule. So let's take a look. Let's take a look at one or two. 3x minus 12 is greater than or equal to 6. So the absolute value is by itself. So we're fine there. So here's kind of what happens. So if it's greater, it's or. So that means 3x minus 12 is greater than or equal to 6, or 3x minus 12 is less than or equal to -6. So 3x is going to be greater than or equal to 18. Here, 3x is going to be less than or equal to 6. So a little division, x is going to be greater than or equal to 6. Here, little division, x has got to be less than or equal to 2. So on the number line, one, two, three, four, five, six, 7. So this is 6, this is 2. Those are my important numbers. It's got to be filled in. But x is greater than 6, and x is less than 2. So it's going to look like that. Okay, so let's put this one back. Let's look at this one. Oh, don't do that. So 3x plus 4 less than 10. Less than means and. Less than, remember? So this has got to be 3x plus 4 less than 10. Just take away the absolute value. And 3x plus 4 greater than -10. So 3x plus 4 less than 10 and 3x plus 4 greater than -10. So then it just becomes inequality solving time. So that's going to be x less than 2. Here, subtract 4, so 3x is less than -14. So when I do that, that's going to be a -4 2/3. Don't complain about fractions. It's not like fractions are illegal. You just have to handle them. So on a number line, 1, 2, 1, 2, 3, 4, 5. So -4 2/3 will be down here. 2 will be right here. They're both open, but since it's and, you go towards each other. So you can either do that or fill in. I don't care as long as you show me that this is open and this is open. So to prepare for a job interview, Megan researches the position's requirements and pay. She discovers that the average starting salary for her position is $38,500, but her actual starting salary could differ from the average by as much as $2,450. So write an absolute value equation to describe the situation. Let X equal Megan's starting salary. So this is kind of an and situation. All right, this is kind of an and situation. Okay, so X is the Megan starting salary. So it's the Megan starting salary minus $38,500. Sorry, I want that to be an absolute value. It's got to be less than or equal to $2,450. So whatever her starting salary is, if it's a little less than 38.5 and I subtract it, it's going to be negative. But if I take the absolute value, that's going to make it positive because you're looking at a distance. So here, this is kind of what you're looking at. Oh. So then solve the inequality to find the range of Megan's starting salary. So this is a less than, so it's an and situation. So if I remember when I do this, X minus 38.5 is less than or equal to 2450, or X minus 38.5 has got to be greater than or equal to negative 2450. Sorry, not or. This is an and situation. So just add 38.5 to both sides in both situations, and you should get your range. So X is going to be less than or equal to 35 plus 2450. That's going to be as big as 40,950. And maybe as low as 3650. So that's going to be kind of what our range is. And I won't make you put that on a number line. That's way too big. So that's kind of what you're looking at for those. All right, just remember you got a little short test coming over all of Unit 1. Get your assignments done.